shop, he's got a neat shirt. It's a white t-shirt, but it's got black graphics of all the different spacecraft, the lunar modules and things like that.
That's so cool.
Because all my shirts are black and they're hot in the summer, but if you get something sort of white, then it's a little cooler.
There you go.
So
good thinking. There we go. So we're up on YouTube now. We've got a few folks joining. I'm going to apologize now because when I sent out the email reminding about this yesterday, I put the wrong time. So I got multiple people being like, you said 1:30 and then the link says 3:30, is because we were advertising the Maori New Year event last week and I just didn't change the time. So I apologize for everyone who's confused by that. Or I apologize to everyone who's confused by that. That was my fault. I will do better next time.
better that it wasn't the other way.
Yes, saying it was, yes, it's true. People have a second chance to come around at 3:30. Hello, everybody who's joining. For those of you, and it's great to see everyone from all over the place here. For those of you who are joining on Zoom, just a reminder, as per usual, that, oh, thank you, Ottawa, for forgiving me. Just a reminder that if you have that little bar that says all panelists, just make sure to change it to all panelists and attendees if you'd like to talk to everyone and not just Chris and I. We're happy to hear from you, but if you'd like to talk to other folks too, you can. And hello to the folks on YouTube as well. Alrighty, and I'll do my best to share links on both. Thanks everyone for joining us. Today, we're going to be diving into some constellations, some specific deep dive constellations. Nice background, Chris. And then we are also going to be talking about some of the sort of more transient objects and cool things that you can see in the sky that aren't just stars and deep sky objects and that sort of stuff. So we're going to talk a little bit about Comet NEOWISE, which if you're in the right spot, you can still see it, but you have to be like in dark, dark, dark skies. And we're going to talk about the International Space Station and about an upcoming event that a lot of folks know about already, which is the Perseids Meteor Shower, which is happening in August, or it's peaking in August. So I'm going to hand it over to the pilot of this show, Chris, for some chat about all that stuff.
Yeah, so thank you, Jenna. Yeah, it just happens that there's a busy period, and even though we had a particular topic set, I thought, it would be a shame to not mention a few things that are coming up within the next couple of weeks to let people know. And the one reason that I mentioned the space station as a topic is that for Toronto, at least, there's a fantastic, extremely bright pass of the space station every single night this week. So it's a great time to go out and look at the space station.
Oh, that's exciting. Oh. Chris? We may have lost Chris. We lost Chris. He'll be back in a second.
Got cut off.
There you are, you're back.
Where did I leave off?
You left off at Toronto's having lovely views of the space station this week.
Yeah, every single night. And it's also apropos.
Oh no, are we losing him again? No, Chris. It's the space station. The space station is cutting him off. Someone's up there. Oh no. I mean, I can talk about it, but I don't want to steal the spotlight. Chris, come back. All right, well, I'll fill the time while Chris has disappeared with how I keep track of the flat earthers have interrupted the stream. So I'll let you guys know how I keep track of the space station. And we've talked about this app previously on this show, which is Astrospheric. Chris is back and he's connecting to audio.
Crazy,
and hopefully
Zoom is killing me.
We're all pretty sure that it's the ISS that's blocking you talking about the ISS here. No, Chris. Chris?
I'm on the air, but Zoom keeps turning me off.
Okay, I'm gonna just keep talking about what I was talking about, which is Astrospheric. So we've talked about Astrospheric before. It's a fantastic app. I've been using it exclusively since we started talking about it. I know a lot of folks don't think that the clouds are necessarily as accurate as they could be, but I really like them, and it tells you exactly when the ISS is going to be going over right there. Sorry, Chris, I was filling the time by probably stealing your thunder.
Let's try it. I don't know. All right.
Who knows? It's all good. So back to the ISS.
So what I was saying was that I've been getting a lot of messages from people who've been asking me about the comet as if it's just a quick thing like a meteor shower, or and I think the problem is that people think of it like firework, like it's just a fast thing that if they're not at the right place at the right time, they miss it. And so I wrote in my skylights this week, and then Alendria has posted it on the Sky News website, a little blurb about how the comet doesn't move as fast as you think it is. And once you find it, you've got like all night to watch it or several hours to watch it. And so people have also confused it with the space station. They see something bright zipping across the sky and they think, was that the comet I saw? And so I thought I would spend, a couple of paragraphs this week in the skylights just to sort of level set people's expectations on how the comet looks. So I recommend you go to skynews.ca and read the little article about the comet.
I just sent the link out in the Zoom chat, and I'm going to throw it in the YouTube chat as well.
So what I'll do is I'll share my screen here, and we'll just review for folks quickly what's going on with the comet right now. So basically, the media made a big splash about the date that it was closest to the Earth, but that was already about a week and a half past its peak. So it was kind of the last good time to see it. And so people are still a little buzzing about it. But if you live in a dark location, you're still in luck. You can still see it. You're not going to see the spectacular naked eye view with the comet, with the tail, but definitely binoculars will pick it up. And binoculars will still work to show you the tail of the comet, even from the suburbs. And let's just show you where we are here.
I'll jump in quickly because I did observe it. So I was out Thursday and Friday last week, and we saw it naked eye, and we could see it looked like it was hard to see. It looked kind of like the brightness of the Milky Way, so it was relatively dim, but you could see the tail on it. I don't know if that's the case anymore because it has been almost a week since we saw that, but it's getting tricky. It's going to get nothing but harder as we go on.
Yeah. So it's basically going to remain a binoculars target for another couple of weeks, probably, as it sort of gradually fades in brightness. But then it'll hang around for telescope viewing for quite a long time, maybe a month or more. It'll just start getting, smaller and fainter, and you'll be able to track it if you can, find an app or a sky chart that shows you where it's going to be. And we've covered already some of the resources that you can use to do that. So this is just a preview of where the comet is tonight. And we were using the Big Dipper as our guide, but I think now the star Arcturus is the better signpost. Actually, is this the right? Yeah, it's the right date. So you probably want to use Arcturus, and basically Arcturus, you can't miss it. It's an extremely bright star up in the western sky after it gets dark. And the comet tonight is approximately, do it this way, a good generous fist's diameter, or 12 degrees to the lower right of Arcturus.
And when, just for those of you who have not been here for that long, when Chris says a fist diameter, he means a fist diameter at full arm's length.
Yeah, so stretch your arm out at arm's length, make a fist and close one eye, and the patch of sky your fist covers is about 10 degrees, depending on if you're a large human or a small human. And but it's basically a bit more than a fist diameter. And the field of view of binoculars is generous enough that you can, let me just bring up the binoculars circle here, something like that. So there's the field of view of binoculars. So what you can do is kind of start at Arcturus and sort of jump 2 or 3 binocular field view sizes down to the lower right. And you might pick up a bonus if your sky's dark. Now the moon is around, so it's going to be washing the sky a bit, but you've got some globular clusters sitting down here as well, and another really bright globular cluster up here. So have some fun exploring.
Hold on, Chris, someone just pointed out in the chat as well, that's actually Pan-STARRS.
Oh, that's Pan-STARRS. I'm sorry. Let's go back. There it is.
NEOWISE. Whoopsie.
Thank you. Yeah, there's actually 3 comets in the sky at the same time. There's T2 Pan-STARRS here. There's U6 Lemon here, and down here there's 289P Bland Plane. But these are dim, telescope needed to see those targets. Yeah, so back to my Arcturus rule. So tonight you can use the tip of the Big Dipper and head on down from there. So you're looking at about, what's that, about 2.5 fist diameters. So what you can do is sort of triangulate from kind of the
There's no big
bowl and the
stars here.
handle and
Yeah.
get yourself down. This star here is Corcorali. It's pretty naked eye, so you should be able to use that sort of to guide yourself down and star hop below. Yeah, my apologies. And over the next couple of nights, I'll just put on the tracking here. Here we go. So that's tonight, tomorrow, the next night, the next night. And within, by about a week, then we're getting into that Arcturus as your guide post. Coma Berenices is not a very prominent constellation, but Arcturus will help you out and sort of triangulate with the Dipper stars. So if you live in a very dark location, despite the moon getting brighter every night, give it a try. Maybe find it with your binoculars and then see if you can see it naked eye after that without them, sort of putting them up and down.
Being able to find it in the first place helps you find the blur afterwards.
And you can still take pictures. So even if you can't necessarily see the comet that well, show your picture, Jenna.
Can I show my picture? I took pictures. It's going to stop your screen sharing. Is that okay, Chris?
Yeah, here, I'll stop it.
Okay, so I took pictures the other night. I took one by accident. This was the first one that I took by accident of the comet and the ISS. And I didn't realize the ISS was coming over at that time. So we saw it actually tracking like down over here sort of area. And then I went, ah, and ran out with my camera to try to catch it. And then the next night I went out on purpose and took this photo, which has it's just 3 photos stacked together of the ISS going in front of it again. So you can't, this was the kind of brightness that we could see at naked eye. It's there, it's just harder to see. Oh, did we lose Chris again? Chris is back.
Very cool, I'm back. Hopefully.
I was very excited about that photo.
All right, so.
I have a quick question from YouTube, actually, from Haley on YouTube. Wait, no, I'm lost in pages. Hold on one second. Let me get to the YouTube page. She was asking if you can go into Stellarium and predict when in 2061 Halley's Comet will be in our view, when we'll see it, where it'll be, all that sort of stuff. Does Stellarium have that much ability?
Yes, in theory. I don't want to go down that rabbit hole today, but I'm happy to do that on a future session.
Okay.
Just because we've got lots to talk about today. But yes, in theory, you can definitely do that.
Okay.
It's out near Saturn right now.
Oh, is it?
Yeah.
Just too far away.
Yeah. Now it came back in 1986 and it just wasn't bright.
Really?
So it's no guarantee. A lot of people were waiting for it and it just didn't pan out.
That's the thing with comets.
That's right. You never know. All right, so let's talk about a couple more things just before we get on to the meat of our topic here. So let me get this under control here. I'm sharing, right?
Yep. Sorry, I'm answering questions on YouTube. You're not sharing because I took it away from you. I apologize.
Okay, let me just share. And share my screen and go.
There we go.
All right. Okay. I'll come back to this in a minute. Yeah, so let's go to now and just jump up to tonight. So this is the week where the moon is in the sky. You talked about the moon in your session with John last week. So that's a great opportunity to check out the moon. And watch Saturn and Jupiter. So over the next few nights, the moon is waxing fuller and heading towards Jupiter and Saturn. And then on the 1st, which is Saturday, the moon's going to land right below Jupiter and Saturn. And what's cool is they'll make a really neat photo, wide field photo. If you pose it with, a landmark, CN Tower, mountain peak, something like that, you can do that. And they'll be together all night. So if you want to, if your sight lines are better, you can wait and do it in the morning. Do it at 4 in the morning or 3 in the morning, and try another one. That'll be a nice triangle by then.
Yeah.
So there's that. And then the following night or a couple nights later, the moon is full. That's the green corn moon. And let's see if there's anything else I want to, I think that's pretty good. A few days later, the moon will sort of hang out with Mars. So let's look at that.
That's something as well to note as with a comet is that as the moon gets fuller, the comet will be harder to see because the moon has cast a lot of light pollution.
That's right. So let's jump ahead. There's Mars. So on around the 8th of August into the 9th. So it's late on the 8th and then into the 9th, early hours of the 9th. You've got the moon really quite close to Mars. So that'll be a neat event to watch for as well.
Ooh.
All right.
We're going to be talking a lot about Mars, just so you guys know, in around sort of September, October time, because Mars will be at opposition and it will be big and bright and beautiful, which opposition is just when it's on the opposite side of us to the sun. So it's as big and bright as it gets in the sky. So we'll be doing lots of stuff on Mars around that time.
All right. So I think we've done our little side topics, right? Or was there something?
The one thing that we didn't do was the Perseids Meteor Shower.
Oh, the Perseids Meteor Shower. Yeah.
The big one.
Right. That's right. That's what I wanted to talk about. Okay. So the Perseids Meteor Shower has actually already started. Let me just bring up the info about that.
That's something the media almost always gets wrong is they're like, you can see the meteor shower on this date. And it's like, you can actually, it's a big long chunk of time. It's just, it's best on that date.
Yeah, so a meteor shower happens because as comets cycle through the solar system, they drop debris. That's what their tail is. And that debris hangs in space along their orbit. And if our Earth's orbit happens to intersect the comet's orbit, then for a period of time, we sort of punch a hole through that debris cloud, and the particles that are floating in space, they get grabbed by our gravity and fall to Earth. And as they're moving so quickly, they basically punch a hole in our atmosphere, ionize a tunnel of gas in our atmosphere and produce that streak across the sky as they're descending. And I've got a neat graphic here that shows this. So those clouds of debris can be narrow or they can be broad, depending on the comet that produced them and how long they've been hanging around in space. And so the Perseids Meteor Shower, this is a 3D graphic of the solar system. So the sun's in the middle, and then we've got, let's see, where's Earth? Let me just zoom in here. Earth is the blue one. So there's Earth. And you can see that at certain times, the Earth's orbit intersects, I've got it sideways, but you can, let me see if I can roll this around. There we go, this way. It's tricky. Yeah. So the Earth's orbit intersects with the comet's orbit, and that's when we get a meteor shower happening. And the Perseids Meteor Shower actually starts on July 17th. So that's when we first start encountering the debris, and it'll last all the way to the 26th of August. But the night that we're actually plowing through the thickest thicket of it is the August 11th, 12th every year. It happens the same dates every year because as the Earth comes around the sun once a year, we're passing through the same part of the solar system on an annual basis. And so we get the meteor showers on a regular annual cycle. So the Perseids Meteor Shower will actually peak on 11th, 12th. And let's see, you can get up to 100 meteors per hour. So, you know, one or more a minute.
That's pretty good.
You can start watching in the evening, even though generally the rule of thumb is that the peak of the shower is occurring before dawn, because that's when the sky over your head is like the prow of a ship that's plowing straight into the cloud of meteors. It's as if you're driving on the highway and the bugs are hitting your windshield. So the sky over your head is the car's windshield before dawn. That's when in our orbit, that's when we're heading forward. So that's why they always say to watch for the meteors before dawn, because
I never realized that.
The other reason is that at that time of the day, the windshield of the car is right over your head. So the meteors can be seen all around that patch of sky, the radiant that they appear to radiate from. If you watch for meteors at a time when the so-called windshield is near the horizon, then half the meteors are going below the horizon and you're not seeing them. So you want to wait till the radiant of the meteor shower is nice and high in the sky, and then you're getting the maximum number possible to be seen. And quick rules of thumb, binoculars and telescopes don't really help because you don't know if you're going to be looking at the right patch of sky when the meteor happens. They're too narrow field of view. You just want to get a chaise, sleeping bag, blanket, find a patch of sky, not too many trees, wide open sky, and just generally look up and just they'll catch your eye wherever they happen to go. And don't stare at your phone.
That
Not
ruins
only
your night
because
vision.
you'll miss the meteors, but because you'll ruin your night vision.
Yeah. And I think that at that time of so the Perseids are, every once in a while you'll see, like the Perseids are going to be extra great this year. And this year's a good year for them because, let me check the moon calendar. I'm pretty sure it's like a late quarter moon.
Yeah, so it's the last quarter moon is happening at the peak. That means that the moon will rise at midnight.
So you got a big chunk of time.
So we're breaking that rule for this time. So you want to watch for your Perseids in the evening, not in the midnight to dawn period, because you'll be sharing the sky with the bright moon.
Yeah. So
it's next year, 2020.
2021.
It's a new moon weekend.
Yes.
Yeah.
Oh, that's going to be good. Last year it was a full moon and it was very sad, I'm pretty sure.
Yeah.
But that'll be great. 2021. Write it in your calendars, everybody.
Now, the other thing to just finish, put a pin in this. I'm just going to here we go. So there's Perseus, the constellation Perseus. And the reason that the meteor showers get their names from the stars the Earth is heading towards or driving towards when the shower occurs. So because we're in an orbit around the sun, we're always making a big turn and we're always pointing at different parts of the sky as we make that turn. And it happens that the Earth is heading towards the constellation of Perseus on the date of the Perseid meteor shower. So they seem to be originating from that part of the sky. And I'm actually going to come back to that in a few minutes on a different topic, and you'll see what I mean in a couple of minutes. So down here in Stellarium, you can actually bring up the meteor showers. So there's the radiant for the Perseids. It sits above the bright star Murphach in Perseus. And you can see that the radiant is high above the eastern sky at 3 in the morning. And earlier in the evening, say around midnight, it's quite a bit lower. And even say 10 o'clock, it's quite low. So half the meteors are going to be sort of disappearing below the horizon. So unfortunately, that's the case. And as far as the moon goes, we bring this up to the 11th of August. So here's the 11th of August. And then we look at the pre-dawn in the 11th of August. So there's that last quarter moon sharing the sky with the Perseids. But if we jump ahead to 2021, there's no moon.
Yay.
So that's what you want.
It's going to be a good year.
All right. So there we go. That's our Perseid story. I'm sure you'll mention them again as well when you do your sessions next week.
We will. And there is one more thing that I'm planning, but I haven't actually put on our website yet. So sneak peek for anyone who's watching this. We have a Discord channel where we chat about space stuff. And I believe we are planning on hosting a voice chat on the Discord channel. So that while you're out observing and looking for meteors, you can come on just on your phone with your phone up to your ear so you don't have to look at it and talk about what you see. Fingers crossed, we're going to have folks from different time zones so that we can keep it going for a while. And it allows you, especially at a time when we can't necessarily spend time with people, it allows you to share things like the meteor shower with people who are out doing the same thing, but without putting you or anyone else at risk. So keep your eye on our website because I haven't actually got it up there yet.
All right. So let's see. How about let's go with let's get into the meat. What were we going to say?
One last thing, because Kareem just reminded me and I forgot about this. So Montreal and Ottawa Center are also working together on a Perseids Meteor Shower presentation on August 8th, where they're going to talk about how to photograph them, how to observe them, that sort of stuff. So that's just before the weekend before the peak. So that'll be up on our website as well, ras.ca, and it'll have the information for that event there.
Fantastic.
That's it for me. Now I'm done. Thank you, Chris.
No problem. Okay, so the reason I noted that in your Explore the Universe sessions, you were looking at some of the prominent or highlight objects in some of the summer constellations, like the ones in the summer triangle. And that's excellent. I mean, those are the things that we want to show people and get them excited about astronomy. But one of the things that I find when I'm doing outreach, and I think a lot of us astronomers that do outreach realize this, is that if we have some facts, fun facts and figures about things in our back pocket, and we're showing them something, you know, that's maybe not an all-star, but maybe just a, you know, a modest star. But if we have a cool fun fact about it, then people will look again. I mean, they get more engaged when they really appreciate what they're looking at, maybe how far it is or how hot it is compared to our sun or some other fact like that. And so what I thought I'd do for the remainder of our time is focus on the 3 constellations of the summer triangle, but kind of tour the stars and highlight some of the cool aspects of those stars and talk about some of the folklore, talk about some of the star names and things like that. So it's a great way to not just, you know, look at the bright, big, shiny things, but also get a deeper appreciation for some of the history and the culture that's in the sky. And so I thought what I'd do here is start with Aquila the eagle. And one of the neat things you can do in a stellarium is you can bring up markings. We've had the ecliptic shown, which is the plane of the planets. But if I bring up the equator, I'm just going to bring up the equator here. So the equator is this blue line, and it divides the sky into the north half and the south half. And that means that any constellation that's sitting near the equator is visible for much of the world, because people who live in the northern hemisphere can see it, and also people who live in the southern hemisphere can see it. A constellation that sits in the north bit of the sky, like Draco or Ursa Major, is invisible for people who live up in the southern hemisphere. And so what you notice here is that the summer triangle constellations, Cygnus, Lyra, and Aquila, are on the equator or just north of it. And so these constellations have been known by many civilizations around the world for, you know, for centuries and millennia. So what can I tell you about Aquila? So Aquila, in the sky, if you have a reasonably dark sky, it does resemble a bird. So you've got a bright star for its head, and then you've got wings sweeping up to either side, and then a tail that hangs down. And in ancient Babylonia, they saw this constellation, they recognized it as a bird. In Greek mythology, this was the bird that carried Zeus's thunderbolts. Ooh. Yeah. The Romans called it Vultur volans, the flying vulture. And the Hindus associated this constellation with the half-eagle human god Garuda. I may have the pronunciations wrong, sorry. Now, if you're from China or you know some Chinese culture, there's a classic Chinese story called The Weaver Girl and the Cowherd. Maybe you've heard this story before. So it's a folk tale. And in this tale, the Weaver Girl, her name was Zhenu, and she was in love with the cowherd Niulang. And to prevent their forbidden love, because you know, a peasant couldn't be connected with royalty, they were banished to the heavens. And Zhenu is represented by Vega, and the cowherd is represented by Altair, the brightest star in Aquila. And they were forever divided by the river, which is the Milky Way. So they were separate, they were destined to be on the opposite sides of the Silver River of the Milky Way. And these little stars beside Aquila are meant to represent their children. So he's separated from their children. But once a year, on the 7th day of the 7th month in the Chinese lunisolar calendar, they were allowed to reunite. And I was taking a Chinese class and I heard this story and I thought, well, that's really interesting. The story is that a flock of magpies would form a bridge, allowing them to visit one another on this certain time of the year. And one day I was thinking about this a little bit and I realized, and I'm just going to bring the sky up a little bit later here, that in the 7th day of the 7th month in the Chinese calendar starts in sometime in January. And so the 7th day of the 7th month in their calendar actually falls late July, early August. And it seems like perhaps the magpies were actually the Perseid meteors.
Oh,
Flying across the Milky Way and bridging the divide for the two lovers.
that's so cool.
I thought that was a cool story.
I love how you can find stories that are more meant to be like a storytelling sort of experience, and then you can find the little bits and pieces that lead to the elements in our sky.
Yeah, exactly. And they're only allowed one day only a year, so I don't know why that is. The Perseids Meteor Shower lasts longer than that. Give them a break. I don't know.
Give them a break, yeah.
So let's zoom in a little bit and talk about the stars in Altair in Aquila. I've got this circle showing here. That's meant to convey binoculars, so you get a sense of the scale of things here. So Altair is Arabic for the word flying eagle, and it's a yellow-white star. It's about 10 times bigger than our sun, and it's only about 17 light years away, which is one of the reasons why it's so prominent in the sky. So it's about the 12th brightest in the sky. It spins fast. It's actually, our sun rotates about once a month, but Altair rotates every 10 hours.
Wow.
So it rotates as fast as Jupiter. Yeah. And that's given the star an oblate shape. So it's got a shorter in the poles and fatter at the equator, an oblate shape. Because we were able to actually get a sense of the star shape because it's close enough for us to sort of image that, get that sense of it. The two stars beside it are Alshane and Tarazed. And this sort of pattern represents weighing scales a little bit. So a fulcrum and two balance points. And so these two star names actually come from Arabic phrases that derive from the word balance or shape. So the Tarazed star is an orange giant. It's 460 light years away from the Earth, and it's almost 3,000 times brighter than our sun.
Wow.
Amazing. Yeah, amazing.
Wow.
And it gives off a lot of X-rays.
Huh.
So, you know, to your eye to the sky, it's just, hey, it's just a normal star. But when you understand the magnitude of it, it really adds another depth to it.
So that's got to be a lot farther away than Altair, eh?
Yeah, so 17 light years versus, what did I say here? Nearly 400 light years.
Wow, that's
Yeah.
cool.
Yeah. Let's see. We have Delta Aquilae. Where's Delta Aquilae? This is Delta Aquilae. Stellarium sometimes uses proper names for stars that aren't necessarily the same names used in many apps. But if you go by Delta Aquilae, you'll certainly find it in another app other than Stellarium. This represents the heart of the eagle, right? So the upper wing star, Okab, this is Deneb el Okab is the name of this star. Stellarium just uses the word Okab. And it translates from the phrase the eagle's tail. So I don't know, maybe they saw a different configuration of the bird when they first named it.
That fits with the name of Deneb, the star Deneb.
Well, the word Deneb means tail.
Yeah, that's so cool.
Yeah, so Deneb el Okab is the eagle's tail versus just Deneb, which is just tail. Yeah,
cool.
The other stars, Al-Mizan, and I don't know why such far apart stars would be given the same name, but you know, somebody had an idea. So, and then down here we have its tail, Al-Thalamane prior. Prior means before, and posterior means after, so prior posterior. So there's probably an Al-Thalamane posterior somewhere, or maybe it's lost to history, I don't know. But this star, the meaning of this star is the two ostriches.
Oh, why is that?
I don't know. Different shapes at different times. Now here's a cool fun fact. The Pioneer 11 spacecraft launched in 1973. It's left the solar system and it's coasting in space toward that star.
Oh, cool.
Yeah. It should get there in 4 million years.
Well, it's still a little bit of a wait.
I don't know how, you know, how much of a near miss it'll be, but there you go. And as
Get
far
ready
as,
for that 4 million year excitement, everybody.
as far as your deep sky, you know, your Explore Universe, your deep sky targets go, you've got your wild duck cluster, open cluster nearby. You've got some other minor things around here as well. This is a planetary nebula. There's actually a neat planetary nebula. If you have a decent sized telescope in a dark sky, there's a planetary nebula here called the Snowball.
Oh.
And it's huge. It's a great big ball, but it's faint.
Oh.
So it's kind of,
cool,
it's like
though.
the Ring Nebula, but it looks more like a sphere than the Ring Nebula does.
Wow.
But if you're up in Manitoulin and you've got your 6 or 8 inch telescope, you'll be able to see it.
I'll go. I might try to take a look at that. For some reason, Aquila just doesn't, like, the constellation doesn't stay inside my brain. Every time I look at it, I go, "That's definitely an eagle," and then it goes doop boop and falls out. So I'll actually try to, like, properly remember it and see if we can find that one. That sounds cool.
Yeah. So that's a cool story. All right, let's move on a little bit. How's our time doing here?
We've got about 55 minutes. Also, folks, no shame in forgetting where all the constellations are. I still, like, the gap, for some reason, again, a gap in my brain. I know where, like, where Lyra or Lyra, where Vega is, and I know where Bootes is, Boötes, and I know where Hercules is, and I just can't remember anything that's below all that stuff. I know it's, now looking, I've been watching, I know it's Ophiuchus and the serpents.
Yeah, it takes a while to learn it, but
it's not in my brain. It won't stay.
All right. All right, I'm just going to turn off the deep sky just to simplify the sky a little bit. So this is the sky. Let's just go back to about 11 p.m. So what I'm showing you is the sky tonight at about 11 p.m. And this is valid for the next couple of weeks. It's not going to make a lot of difference, but the Z here represents the zenith straight overhead. So you'll notice that the star Vega is close to straight overhead. And we talked about the fact that that's the best time to look at objects is when they're high in the sky, because then you're looking through less of Earth's atmosphere. And so you get less diffraction and dimming effects from the Earth's atmosphere. So let's talk about Lyra next. Okay, so let me just find my notes here. So you've talked about Lyra before, and you've talked about Lyra in your Explore the Universe session.
Yes, though not everybody who joins here goes and sees it. So if you want to repeat some stuff, it's okay. It's nice to hear it multiple times.
So Lyra, and let me just put on the art. I could have done that for the eagle as well. Mm-hmm. So Lyra represents the musical instrument, the turtle shell instrument that was strummed by Hermes, and it's also been assigned to the instrument that Orpheus was strumming in mourning of is it Eurydice, his love that got taken to the underworld.
Oh wow!
I forget her name, but so it's been assigned to a couple of different Greek stories. Let's see what else we have. Of course, in Canada, we call this constellation what?
Is it
the Tim Hortons constellation?
Yeah. There's a good reason for that.
Yeah, it's because it has a coffee and a donut in it.
It sure does.
We've covered that already before, but we can go in there. We can go there again. Now let's see.
I want to make sure everyone's in on the joke. Just in case there are folks here who are not in on the joke.
All right, so let's do our little tour. So Vega is the brightest star, not only in the constellation, but it's the brightest star in the summertime sky. So Vega is also known as Alpha Lyrae. The alpha, beta, delta, gamma names that you hear with stars are a system that was put together to kind of name the stars according to their brightness. So generally the brightest star in a constellation got alpha, and then beta, delta, gamma, and so on all the way down the line until they ran out. And then they would start merging them up. Most of the time it works. Sometimes if a star has varied its brightness over time, or if a star is variable, it might fade and become the second rather than the first. Things happen, but Vega's no doubt about it bright, and so it's the brightest star and it's alpha. couple other things about Vega. Vega is got a magnitude of 0.00. And that's because, yeah, that's because it's the base level for star brightness. So Vega was chosen to be the 0 point. And then stars that are brighter would have to be more negative than that value, and stars that are dimmer or more positive than that value.
Vega is sea level.
Vega is sea level for star brightness. Yeah. Let's see. It's the fifth, even that said, it's the fifth brightest star in the night sky. That's partly because Sirius is brighter and it's visible in North America and Canada, but many of the other brighter stars are only visible from the southern hemisphere. So Alpha Centauri and Canopus and stars like that are brighter. It's about 25 light years away, and it's very, very hot and luminous, of course. And its name comes from the phrase al-Nazir al-Waki, or Vega. And that translates roughly into swooping eagle. And that's because the original depiction was the eagle was carrying the tortoise shell or the turtle shell of the harp, sort of dangling below it. So nowadays we sort of sometimes think of Vega as being the kind of the neck of the instrument, but really it was meant to be just a box for the harp and then the eagle carrying the harp across the sky. Vega is actually heading in our direction towards the sun. Ooh. And it's going to brighten over hundreds and thousands of years. And eventually it will become the brightest star in the night sky in about a few 100,000 years from now.
Ooh.
So it'll climb the charts and become #1.
Oh, that's so cool.
The Earth's axis wobbles in a big circle as it goes. As we spin, the Earth spins. Our northern axis actually precesses like a top. And 12,000 BC, so about 14,000 years ago, the pole star was close to Vega. In fact, I think I can simulate this if I show you the equatorial grid. And if I set the date, let's see if I can set the date.
Can you go back that far?
Minus 12,000. Let's see if I can find.
Wow.
There you go.
That's so cool.
So that had been what is now Polaris used to be Vega.
Wow.
Yeah.
I didn't know you could go back that far in Stellarium.
Yeah, you can do that. And that will happen again in +14. So let's see if I can do this. +14.
Yeah.
So it's about a 30,000 year cycle.
Wow.
Right, let's go
back.
That's
very cool. That are we switching constellations, or should I save questions for later?
No, we're staying on Lyra for now.
We'll save. Okay, I'll save some questions until later. But just so you guys know, I see them and I'm going to ask them later. I promise.
Yeah, I think we'll have lots of time for questions today.
We've got really two really good ones. I'm looking forward to them.
Okay, yeah, don't lose them.
I won't lose them.
Okay, let's see. Okay, I told you the story about Vega being the princess. So that's okay. All right, now this little star here, just to the left of Vega. Let me just zoom in a little bit for you here. And again, if you put binoculars around them, and you've talked about this already, but we'll recap it because this is where the coffee comes in. So this gap between Vega and this star is about a finger's diameter. So close one eye and put your finger out in the sky. And this is also about a finger's diameter. So this, in a dark sky, you can see a little triangle of Vega and two other stars making a triangle. The one here, if you've got sharp eyes, you might notice that it's a double star. So at casual glance, it looks like a single. But if you have good eyes, you might see it's two. Binoculars will definitely show it's two. And this star's nickname is the double double, which is where the coffee comes in. And its official name is Epsilon Lyrae. So it's down A, B, C, D, E, Lyrae. And if we zoom in on the double double and keep going, each of the stars splits into two. And so your backyard telescope, if it's a reasonable size, 100 millimeter or 80 to 100 millimeters refractor, or a 4, 6, 8-inch reflector should be able to show if your seeing is good, if your air is steady, that star is actually 2 stars close together. And usually in the eyepiece, you can get it so that you can see them both at once. And there's a trick in stellarium that actually makes the star blobs smaller. So I'll do that. So if I shrink these down, you can see
there's the double, double.
Double is itself double. So it's a double double. And the current thinking is that these 2 stars are in orbit around one another, and these 2 stars are in orbit around one another. And somehow this pair is orbiting this pair or vice versa. So it's like a big square dance over many thousands of years. And the longer that we are able to measure the motion of these stars, the better we can refine the orbits. When we had Blake on, he talked about this particular system then.
And this is an apt point to remind folks that if you want to see previous episodes of the Insider's Guide to the Galaxy, they're all up on YouTube as well. So if you're particularly interested in double stars, we have a whole session just about double stars that you can go and watch retroactively on our YouTube channel. And this one will also be available on YouTube.
So you can see that if I click on the star, I get the distance from stellarium. So that's 160 light years and 162 light years. So they're in the same little neighborhood.
And that answers the question that just came up, which was how far are the double stars away from each other, and then how far away within the pair. So the 2 light years away from each other in the 2 systems, eh?
Well, at least radially. I'm not sure.
Oh yeah.
We can look it up though. If you remind me, we can look it up.
I can take a look now. We will see what I can find. I'm not as good a researcher.
Okay. Let's see. I may have had it in my notes, but I'm sorry, I don't.
That's okay. I'll take a look.
So this little star, so I said that there was a triangle here with a finger's width in between each of these roughly. So this star here, and this is where the fun comes in. We've mentioned before that every corner of Lyra is a double star. And some are easy and some are a little harder, but this one is relatively easy. So even binoculars, you might start noticing that it's double, but if you zoom in with a telescope, backyard telescope, you can see it splits into 2. So that's Nazar al-Waqi, or otherwise known as Zeta Lyrae. Okay, both are kind of whitish. One is a little brighter than the other one. These are 152 roughly light years away from us, 156 light years away from us. We do get different distance numbers from different apps and different sources because we're constantly measuring and refining the distance to stars. So you'll get some contradictions sometime, but generally the number will be about right.
And I've got a bit of an answer for Epsilon Lyrae. Do you mind if I share my screen quickly?
Sure, go ahead.
Okay, sorry. I'm just gonna, because I'm only just reading this at the same time. So it looks like they're measuring separation between the stars and like the coupled stars in arc seconds, and also so arc seconds being like parts of a degree.
Part in the sky, yeah.
Yeah, like a certain part of a degree. And then AU being astronomical units, which are the distance. 1 astronomical unit is the distance from us on Earth to the sun. And so between the 2 pairs, it looks like about 10,500 times distance between us and the sun. And then between 1 pair of 2 stars, it's about 116 astronomical units, which is pretty darn close. So 116 times distance between Earth and the sun, and the other one's 121.
So that's crazy. That would be as if we had another sun out there in the Kuiper belt.
That would be insane.
Yeah, and then we had another pair of suns out beyond the Oort cloud.
That would be crazy. That'd be so cool.
Yeah.
Our sunsets would be incredible.
Yeah. So,
Anyway, so
you see what I mean about astronomy gets way more cooler when you start finding these deep.
Oh no, Chris. Oh, that's the sound of Chris going away. But it is cool. It's so cool to find these little to picture life on other places, and to be able to find these neat little facts about different objects out there. Okay, while Chris is readjusting, I will answer Adeya's question. Yes. Oh, unless he's back. Chris, are you back?
I'm back, I think.
Okay. If you disappear again, and he disappeared again. Okay. Aditya, I'll answer your question, which is, oh wait, are you back for sure now, Chris?
I think I'm back.
Okay, okay. All right, I just wrapped up your comment in that it's, oh, it looks like you're gonna go away again. Okay, while Chris is away, Aditya asked, how do these constellations get their names and the shape that we see? Sometimes they see no relation between the shape application or that stellarium shows and the lines created by the stars. That is a very good question. That happens a lot. If you look at either Vulpecula or Canis Minor, those two constellations, they're two stars and connected by a line. Sorry, Chris, I'm answering a question in your absence, and I'm going to keep answering it until you stay here for a longer period of time.
Yep. Carry on, carry on.
Which is how the constellations get their names. And so sometimes it'll, like, different cultures see different things. So for example, in many northern communities, the Big Dipper was seen as a bear because there are often a lot of bears in northern communities. And so that seems a little bit more familiar to the folks up there, whereas it's seen as other things like a gourd or a plow in other areas. And actually in indigenous culture near where I spent some of the year up on Manitoulin Island, in Anishinaabe culture, in Ojibwe culture, it's seen as a fisher, which is another animal that's close by. So sometimes it's based on what's nearby, sometimes it's just based on storytelling. Really, the constellations that we have settled on, as it were, in the Western world are almost all from Greek culture. And I mean, really, they're just made up, right? Like, they're just stuff that people see up there and they go, that kind of looks like this thing. Let's agree that that's what we're going to call it. Like, it's not really a science in that manner of deciding what it looks like. It's more of an art. And then we use it as a function when we're doing science. When we want to find stuff in the sky, we can say, oh, it's inside of this constellation. It's less so about what it looks like and more so about where it is. Does that answer? Hopefully that answers. If you have any other extra opinions, Chris, you're welcome to throw them in.
Well, for example, in China, they have, in classical Chinese astronomy, they have more than 200 constellations.
Oh, wow.
So they just had much smaller constellations.
And sorry, one last one. In Incan storytelling of the night sky, they have dark constellations. So they're the dark spots that you can see in the Milky Way. And those are meant to be the living constellations. And then the stars are these sort of more static ones.
All right, so let's see if we can hang on and tour a little bit more. So here we have the parallelogram box of Lyra. And again, we were starting up here at Vega. Now we're sort of touring around the perimeter of the box. We talked about how this is a double star, Zeta. Okay, and then moving clockwise, we go down here to Sheliak. So Sheliak is Beta Lyrae. Okay. Sheliak means harp, comes from the word harp, and it's actually a double star, so we can magnify that. You can see how it comes apart. It's actually multiple stars. Okay. So this one has Sheliak, the primary of the two, the brighter of the two. It has a little partner that orbits it every 13 days. And so this star actually varies in brightness when the partner passes in front of that star and blocks Sheliak slightly. So we get a noticeable drop. It's called an eclipsing binary star system, where one star, from our perspective here on Earth, its orbit is aligned up so it passes in front of the other primary star every 13 days. And then down here, we'll just pass by that little disk there for a second. So now we're looking at I'll put the artwork away. So that's Sheliak. Then down here at the bottom corner, the lowest corner, we have Sulafat. Okay, so Sulafat means turtle. Comes from the word turtle. Ooh. It's a hot blue giant star. Okay, it's 620 light years away. It's similar in color to Vega. So you can notice when you're out, try to note the star's colors as well as their brightnesses. So that's important. That tells you a little bit about their temperatures. So a white star, a bluish star is hotter than an orange star or a yellow star or a reddish star. Okay, so Sulafat, that's
a quick question about Sheliak.
Yep.
And you may have answered this, and I'm sorry, I was also answering questions in other sections of the chat. Can we see Sheliak double stars through binoculars?
It would be tough. They're a little narrow, they're a little closer together.
Okay.
But yeah, if you've got even a weak even a small backyard telescope would be enough to split them apart though.
Okay, thank you.
Yeah. Sulfat. So sulfat means turtle. That's the one at the bottom here. Okay. And that's the eclipsing binary system that I was talking about. Let's see. Oh, no, that's the eclipsing binary. Down here is the sulfat, and it's actually an orange on its way to becoming an orange giant star. So one day it'll sort of change color and swell up as an orange giant star. And then we'll come back to this neighborhood in a minute for the donut. But
yeah, we got to get that donut alongside the double-double.
Right. And finally, the last quarter is Delta Lyra. And Delta Lyra, these two stars are considered double, and they're easy naked eye, no problem at all. So naked eye or binoculars. So you've kind of got a whole range of easy, medium, hard, harder, and then harder double stars in the corner of the four corners of Lyra. All right, let's go to the donut. Now, what I love about this object, the donut, is that it's so easy to find for anybody who has a telescope, because all you need to do is use your viewfinder or your finder scope or your red dot or whatever you're using on your telescope, and just point it between sulfat and Chelyabinsk, and start out with a long focal length eyepiece, like a high number eyepiece that gives you a low magnification. Aim your telescope exactly between these two, and you're bound to pick up the Ring Nebula. We talked about the Ring Nebula a couple weeks ago.
Delicious.
Ring Nebula is a planetary nebula. It's the expanding shell of a star that's had a similar mass to our sun. It exhausted its core hydrogen, and then went through a process of death, which eventually led to the star blowing off its outer shell and leaving its hot core as a white dwarf star. That's the little white dot in the middle. And that white dwarf star is millions of degrees. It's cooling over time, and its radiation is causing the gas in the former shell of the sun to glow with different colors according to the composition of the gases. And so these stellar corpses are scattered all over the sky, all different shapes and sizes, and they're transient. They only last a few thousand years before the cores cool off, and then they sort of fade to invisibility. And they're part of the kind of the galaxy circle of life, if you like. So our sun will turn into an object like this in about 5 billion years when it reaches the end of its life. And so that's what we call the Ring Nebula, or the donut. So you've got your coffee and your donut.
It's perfect. It's as Canadian as it gets, except for Delphinus, which I always call the hockey stick constellation, which is also nearby.
Now there's another one in here that's in the area. Let me just pull this up. Okay. In my notes. Yeah, so another thing you can do to use Lyra is you can actually draw a line from Chelyabinsk to sulfat and jump down about 2 diameters, and you can find this globular cluster in Messier 56. So that might be your Timbit.
That's perfect.
If you want to stretch the analogy. All right. Questions? You want to go back before we go on?
Sure. There's one question that's relevant, and I'll save the other one for the end because it's more of a general question. Or actually, there's 2 others that are general. So the specific one is, with a focal length of 650 millimeters and an aperture of 5 inches, would you be able to see the Ring Nebula? And I think the answer is yes, eh?
Oh, yeah.
And follow up that, you can actually set stellarium up with your specific telescope, and I think, right, and change out eyepieces and everything, so you can see what your telescope would see. Is that right?
You can do that. You can actually, yeah, you can edit it to put in your focal length, your eyepiece, your aperture, and so on. You can also find a telescope math calculator on the web, and you can plug in your numbers, and it'll give you the field of view that every eyepiece you own will have. And then you can go ahead and make your circle match that field of view. So you could also get a sense of the scale of things that way and do it that way.
That might be easier. I've had trouble with the programming stellarium to have your telescopes in it kind of thing. I can't get a handle on it, but some people can. Some people who have had more experience with stellarium than me, that's for sure.
So the field of view of a typical backyard telescope with 10 or 25 millimeter eyepiece, that kind of thing, is generally about 1 degree. And so that sort of gives you a sense of the degree.
That's very helpful. And also a reminder, I think it was, sorry, I've lost track of who asked that question. Aditya, maybe again? Yeah. A heads up that light pollution matters more at this point for the Ring Nebula, because the Ring Nebula is relatively dim-ish, magnitude 8, right? It's not that bad.
Yeah, and that's the other reason why it's neat to talk about the different stars in the constellations, because you can really enjoy them even when the moon is up. You know,
yes, stars
when
are great.
when I'm telling you about the star colors, when I'm telling you about the doubles and the multiples, you can look at them anytime. The moon can be there or not, it doesn't matter. Whereas the ring, you kind of wait till a moonless night to see it. One more little cool treat in Lyra is if you kind of make a triangle with Sulafat and Sheliak inside the box, and look at that star. It's actually a double star of 2 different brightnesses, 2 different colors.
Wow.
It's very similar to Alberio.
That's cool. I didn't know about that
So
one.
it's like a false Alberio. Yeah. Yeah. So let me go back to my binoculars view here. I'm just going to change this back to the binoculars size, just so we're sort of consistent. Yeah. And that's, I think it's, yeah, it certainly would be naked eye on most nights, you know, maybe not when the moon is super bright, but you can pick that up.
Cool.
So that's Lyra. Lots of neat little things.
Yeah.
All right, now let's turn our attention to Cygnus. Now Cygnus is cool. All right, so there's a lot of reasons why Cygnus is cool. Now, bear in mind that I've got my equator showing here. So you can see that Lyra and Cygnus are quite a bit above the equator. So they, you know, they're favored more in the northern hemisphere and equatorial locations on Earth to see those, as opposed to things that are on the equator, like, you know, Aquila's on the equator, Orion's on the equator. Some of these constellations that are so famous are partly that way because they're bright and because they've been visible from all over the planet, whereas some of the more northerly ones, not so much. All right, so here's the sky. Again, we're talking about 11 p.m. and we've got Vega up here near the zenith, and then we've got Cygnus just down to the lower left of it a little bit. Let me just find my Cygnus notes and bring those up. Okay, this should be it. Okay, now. And these constellations, by the way, they're visible all through the summer and fall, till almost December. So you can really enjoy them for a good long time.
So this is a really cool thing, and I always found this a little bit of a misnomer. This is the summer triangle, or sorry, the 3 stars that in these 3 constellations that are the brightest make up the summer triangle, because it's a triangle that you see in the summertime. Except because of the rotation of the Earth and the changing, essentially the sky getting darker as we get closer to winter, you can see it all the way until December, which is like, yeah, okay, it's a summer triangle, but like you're looking at it, and you can look at it in the fall and even in the winter if you want to. Anyway, whatever, it's fine.
Exactly. Yeah. As it sinks into the west, the sky's getting dark faster, so
this kind of outpaces it. Yeah.
Yeah. All right. Let's see. Let's talk about Cygnus. So sometimes it's called the Northern Cross, right? Because it looks like a cross. Okay, as opposed to the Southern Cross. And we're going to do our tour of the Southern skies one of these days and look at the true Southern Cross. It's the 16th largest constellation in the sky. And because it's so far north of the equator, some of its stars are circumpolar. So they never set for Southern Canada.
Oh.
Okay. It's one of the constellation that really resembles what its name is. Okay. In Greek mythology, Cygnus was, Zeus took the form of the swan to seduce Leda, the mother of Helen of Troy. That's one of its representations. Sometimes it's meant to represent Orpheus, and Orpheus was again strumming the lyre, the same Orpheus we talked about a little while ago. The Arab people, they saw this as a hen. The Dakota people of North America saw it as a salamander. And maybe they're looking more at the wings in that case. The Ojibwe people name it the crane, for obvious reasons. The Mongolians saw it as a bow and arrow.
Oh, cool. I like that one.
Yeah. And the Chinese thought it was a bridge crossing the river of the Milky Way,
Huh.
which runs up this way.
That also works. That's a good way to find the Milky Way if you're having trouble seeing it. It goes right through Cygnus, or Cygnus goes right through it.
So that's one of the cool things of Cygnus, is that she's almost flying down the Milky Way as if she's coming in for a landing on the river, or maybe just taking off from the river. Now, the star Deneb, which is Alpha Cygni, the brightest star, it's, as we indicated before, the word Deneb comes from an Arabic word that means tail. So this represents the tail of the swan, or of the crane. It's 1,500, almost 1,500 light years away, or 1,411 in this app. So it's really far away, but it's so luminous. It's many tens of thousands of times brighter than our sun. And so we can still see it as a very bright star, even though it's so far away. So don't forget, it's not a lot dimmer than Vega. Vega is only 25 light years away. Deneb is 1,411 light years away. So that's how much light it's pumping out.
Wow.
Crazy. Deneb will also become the Polaris in the year 9800.
Oh, it will?
Yep.
Oh, I never knew about that.
So the pole precession circle passes through Deneb as well as Vega. Actually, I think I can do pole precession on my markings here. Let's see. Circumpolar. No, that's not what I want. Precession circles.
Oh, there we are.
There we go. There we go.
Oh, cool.
That's the pole precession circle you can see right now. Polaris is on the circle, and as the Earth's axis wobbles, it'll go through Cepheus, pass near Deneb, pass near Vega, and then eventually end up back at Polaris again.
We are lucky here right now, right here in the Northern Hemisphere, that we have a star close to the pole, because the Southern Hemisphere doesn't have one, and really it's just a fluke.
That's right. Okay. By then, in 1,000 years, they'll have more fancy ways of aligning their telescopes, if we can still see the stars.
Oh no, that was a joke, but it made me sad.
All right, so that's Deneb. We'll come back to this in a second. In the middle of the constellation, we have the star Satyr, or Sadar. I'm not sure how it's pronounced, but it actually means the hen's breast. It's farther away than Deneb, 1,832 light years away.
Wow.
And so it's also extra luminous. It's a cooler spectral class. So Deneb is, or its spectral class is an A star. And this one is a F star. So it'll be a fine girl or guy, kiss me. So it'll be AF. So A and F are neighboring classification settings, but one is slightly cooler, slightly sort of warmer in color than the other one. Okay, and then heading out in the same direction, we're going to come back to Eta in a couple minutes. We find Albireo, and Albireo we've mentioned before. You've mentioned it in the Explore the Universe. Albireo is our summer showpiece double star, which in a backyard telescope splits into a beautiful 2 different colors, 2 different brightnesses. It's about 385 light years away. And again, we talked about this with Blake, the potential for these stars orbiting one another as well. By the way, this star's name is Albireo, even though it's 2 stars, and that's because stars were given their names before telescopes were invented.
Oh.
So nobody knew it was 2.
Huh. That's neat. I mean, I guess, yeah. So you wouldn't be able to give it a second name. I guess that's why Mizar and Alcor do have 2 separate names, is because they're just barely visible naked eye.
That's right.
Those are the 2. That's the double star and the Big Dipper's handle, for those who do not know. Yeah.
Now, once you've got Deneb and Satyr, and then looking across to Albireo. Albireo is quite a bit dimmer than the other 2, but you can pick it up, sort of extrapolate across. Then you can come back to Satyr and start going up the wings and down the wings. And these are several modest brightness stars. They're naked eye, but they're not big bright ones the way these the tail and the heart are. And so Going upwards from Saturn, up the wing, we have Phawaris or Alphawaris, which means the riders.
Oh.
Okay. It's also been called Rook after the mythical bird, the Roc, R-O-C,
Oh.
in mythology, the, you know, Jason and the Argonauts, that kind of
Yeah.
thing. Some of the sword and sandal movies. Decent telescopes should be able to split the star into two. There we
Oh,
go.
yeah.
So it's, you need higher power to do that, but you can split it into two stars. Okay. Let's see, what else can I say about this one? And then we can come to Iota Cygni, and then Kappa. For whatever reason, its stellarium calls this Phawaris 1 and Phawaris. I don't know why that is, but anyway, that's the way it goes. And then along the way, you could sort of detour over and look at Omicron 1 and 2 Cygni. That's a wide double star that you could pick up with your naked eyes, no problem. Now heading down the wings, okay, we have, let's see, Epsilon Cygni. So this is Epsilon Cygni. Sometimes it's called Genia, G-I-E-N-A-H, or Algena, as you can see it, stellarium uses here. It comes from the Arabic phrase for wings of the swan.
Oh.
This star is starting to die. It's at the beginning of its death process. Okay. Now heading down, we have Zeta Cygni. This is an orange giant star. So it's, let's see, 143 light years away. Okay. And then carrying on, we have Mu Cygni. And this is a tight double star. And you can see that there's a bright one and a little tiny companion star. So that's sort of big and small.
It's fun just to kind of bounce around the constellations and look for double stars. There's so many of them.
So this one is, let's see, about 70, where are we here? Mu Cygni. Find these, yeah. Yeah, so that sort of gives you an idea of some of those. Now, let's see. Now we can get into some of the cool deep sky stuff. So not a good week this week with the moon getting bright, but in about 2 weeks when the moon starts getting out of the picture again, you can get out with your binoculars and enjoy the Milky Way as it passes through Deneb. And if you've got a nice dark sky sight, you can look below Deneb for this sort of enhanced pinkish patch. And that is the North American Nebula. We talked about that a couple of weeks ago. And the reason that it's pink is that it's glowing hydrogen gas. And then right above the North American Nebula, can you see there's a pelican shape? Here's the bird, here's his head, here's his beak coming down.
Okay.
So that's the pelican. Same cloud of gas, just separated by dark dust. Okay. And then up around Saturn, there's another concentration of gas. Again, this is right in the plane of the galaxy. So we're getting the star forming regions in the plane of the galaxy. Okay. Let's see, I want to talk about Messier 29. Where's Messier 29? Here we go. M29. So M29 is nicknamed the cooling tower.
Oh.
And that's because, let's see if I can get the deep sky image of it. The stars, I'll turn these off here for a second. The stars sort of look like two diverging rows. I don't know if you can see here. So we've got 3 stars sort of in a bent line, and then another few stars kind of in a bent line. So it kind of looks like a nuclear power plant's, you know, graceful shape, cooling tower shape. So that's why they call it.
I could see that.
Cooling tower. All right, turn that off and put the stars back on. So that's M29. That's just below Saturn. You could pick that up with binoculars or a small telescope. And then down here, and again, we mentioned this a couple of weeks ago, this is actually the Veil Nebula. And it's easy to find if you can see this naked eye star 52 Cygni and put your telescope on this, and then look for a dim band of light that's passing through it. And this is the edge of a supernova that exploded, we think, several thousand years ago. I have my notes here. Yeah, about 5,000 to 8,000 years ago. And actually, you can see that it's so big that binoculars are better if you have a dark sky. Okay. So
Sorry, I was answering a thing. Did you say you can see that with binoculars?
You can if
If you
it's
have
a
dark
really
sky?
dark black sky.
Okay.
Yes. Yeah,
Okay.
yeah.
Good to know. Good to know.
I mean, what you do is find, so you're coming down, what the trick is. So start with Deneb and Saturn,
Mhm.
come down to one joint of the wing
Mhm.
and the next joint of the wing, and just sort of look for 52 Cygni, the
between.
star,
Okay.
just off to their right, and then put your binoculars sort of on that and look for the
Okay.
glow.
Okay.
You know, parts of it'll be brighter, dimmer. See what you can do. That'd be great. Give it a
Cool.
try.
Let us know next time. If you go out and do that, let us know next time if you can find it. I'd be really curious to see. I'm going to try to.
Another one that's good in here is below Deneb. Oh, that's not the one I wanted. Let's
Oh,
see.
cute though. Pink pillow nebula.
Yeah. You can see there's all these little symbols represent, you know, individual deep sky objects. The one I want is up here in the upper wing. And that's the blinking planetary. So that's another one of those stellar corpses. And this is the one where you can use averted vision. So in your telescope, if you look straight at the object, you'll see the bright star in the middle, the white dwarf star, and not so much the shell around it. But then if you look away at some of the other stars, the bright star will disappear and the bright shell will get brighter. And you can flip back and forth so it blinks, bright, bright, dim, bright, dim. So that's that one. And final thing I wanted to talk about was back to the neck of the swan. So you can see that as we go from Deneb to Saturn and then out to Albireo, I'll just bring it up a little bit, there's a star along the way, a reasonably bright star along the way. That's a naked eye star. And that star's name is Eta Cygni. Now, back in the 1960s, astronomers were starting to map the sky in X-rays. And so they were launching rockets. X-rays can't penetrate the Earth's atmosphere. So they would launch rockets and make maps of the sky. And they discovered that there was a bright X-ray source in the constellation of Cygnus, not far from that star. Okay. And astronomers started to chase down these X-ray sources to figure out what they were. Okay. And in 1971, around 1970, 71, Professor Tom Bolton, who worked at the University of Toronto at the David Dunlap Observatory, I've heard in his spare time, I'm not too sure, but he studied the X-ray source. He pointed the telescope in the spot of the sky where the X-ray source is. And I think I can bring up the star name here. The actual star that he was looking at is HD 226868. It's right here. So it sits near this naked eye star, Eta Cygni. And if I just bring in the telescope view, let's see if I go with a 1 degree view. Okay. So if you point your telescope at Eta, and remember your telescope might flip the view around. So this star might be up here if you're looking through a telescope. This is the star that was closest to the X-ray source. And he took spectra with the 74-inch telescope at DDO, and he discovered that something invisible was tugging the star, yanking the star around. And as it yanked the star around, its spectra would be red shifted, blue shifted, because it represented the motion of the star being tugged around the sky. And so he published his results, and it turned out that he had discovered or confirmed the very first black hole in history by humans. So this is Cygnus X1. This is the Cygnus for the constellation, X1 for the first X-ray source, and it's the first known black hole that humans discovered, and the David Dunlap Observatory telescope got credit for finding it.
Which is so cool. It's such a neat Canadian discovery.
Mm-hmm. He actually had competition. There were astronomers in Britain that published around the same time. So if you look in Wikipedia, they don't put his name first. I don't know why that is, but.
Well, they should.
But they should. Yeah.
That's very cool.
And then of course the rock band Rush wrote a song about it.
Right, yeah. So I found that out recently and I went and listened, or I didn't listen to it. I read through the lyrics. It's very cool.
So you can definitely see Eta with your naked eye, and you can definitely see the star. It's also known as V1357 Cygni, or, you know, all these different catalogs that the stars come from. But it's a little sort of a double star. You can find it to the, it's about, let's see, about a half a degree, I think. So about your pinky fingers width to the lower left of Eta Cygni. So that's all I had prepared.
Cool.
Sorry, that's it.
That's it. That wasn't enough, Chris. We still have 10 minutes. Come on, man.
So what do people want to know?
So there are a couple questions. If you have more, please ask them now. In the YouTube chat. I'm not watching the Discord channel. So if you're asking them in the Discord channel, I will not see them unless my coworker Eric sends them to me. So he did do that with one of them. Those are good questions. We'll get to that. First of all, I think this was to do with the Ring Nebula, the little planetary nebula. Is gold made from those types of stars explosions, gold specifically? Which I don't think it is. I think it's made in supernovae.
Yeah, we now think that the only way to really get heavy elements, sort of platinum, gold, silver, things above iron in the periodic table, is through a more violent event, like a supernova explosion, or maybe the merger of neutron stars or something like that.
Yes, neutron star mergers are.
Yeah, the LIGO experiment detected the merger of some, I think it was neutron stars, or maybe a neutron and a black hole.
Something
and
like
the
that.
spectra indicated that there were heavy metals, heavy elements produced in that event. So we didn't know that until LIGO, but now we think that that's another way of making heavy elements.
So essentially, since we have heavy elements here on Earth, it means that other stars exploded first before our solar system formed. And that is why we can have elements like gold and heavy stuff that we do. Yeah.
This is where you get gold.
Yeah.
Supernova remnant, supernova explosion.
The big flashy one.
Yeah.
The other question, and I have a half answer for this, which I've sent out in Discord already, was, is there a guide somewhere that just has binocular targets? Like a website that lists binocular targets, anything like that? I've pointed towards a volunteer from Halifax, Tony Schellink, who made a program called the ACE Astronomer Program. And it's literally just binocular specific. So there is the link in the chat, and I'll throw it on YouTube as well. And it has, even if you don't go for the program, which you can't, I don't think, if you're not in Halifax, but I may have to correct myself later on that. We'll see. Even if you don't go for the program, that has a list of targets that are visible in binoculars. So that's a good start. The Explore the Universe program that we're running on every other Thursday, the Thursdays of the weeks that we don't run this course, that also is meant to be done with binoculars, so that you can see everything in there in binoculars. And we also have another observing certificate called Explore the Moon, which is all binocular, or there's a binocular version if you wanted to do the binocular version. Apparently, there's also a book by Gary Saranic, which is called Binocular Highlights. Was that what you're about to say, Chris?
And I think I think Stephen O'Meara also has a binoculars object book as well. So there are quite a few good ones around.
Okay.
Yeah, and the skymaps.com monthly sky chart, I think, I can't remember, but I think this came up recently in one of the sessions. It has sections on the back, on the flip side, with binocular targets, naked eye targets, telescope targets, and it's updated every month. Skymaps.com. Okay, cool. It's a PDF you can print out.
Sweet. So that should cover those questions. Okay. Linda asks, there's a gold pair of stars in Cygnus that were used initially to measure distance. Is that 61 Cygni? And how do you find it? I actually have no idea what you're talking about, Linda. I'm sorry.
Let's see.
61 Cygni. 61
Cygni. Okay. So that's where Cygni 1 Cygni is. Bessel star?
Bessel star? It is. There are two stars there. Let's see.
Let's see what they say.
To the internet, quickly.
Yeah. 61. That's the great thing about astronomy, is you learn new things all the time.
Yeah. Linda's also a very experienced astronomer. I know Linda, and she knows what she's doing. Yeah, Friedrich Bessel measured its distance from Earth.
Okay. Large proper motion. Yeah. Okay. So what that means is that as the stars sort of jostle inside the galaxy, well, when a star is formed, it's part of a cloud that was probably rotating, and so the star has a motion inside the galaxy, and some stars move across the sky more rapidly than others, and it seems that Bessel's star was known to have a fast motion through the sky, and he used that, I guess, to infer its distance by how much it was moving.
And that seemed to be the first time that anyone ever did that, eh?
So if I pick a star here, let's see if I can advance. Can you see that?
Oh, cool.
Yeah.
That's even over a year.
Yeah, so there's now, and here's a year from now, next year, next year, next year, next year, next year, next year.
Okay, so for the really committed of you, go out and observe this star and track it over like 15 years. That's so cool.
Yeah, so this would be called a high proper motion star.
Wow.
Yeah. So it's a magnitude 5.2. It's, naked eye, but certainly binocular range. So yeah, you can find it.
Let's see if there's anything nearby. Is there anything? There's not much nearby, eh?
Well, so here's 52. So here's where the Veil Nebula is.
Yeah.
Here's where that first joint of the wing is. And so it's kind of.
It makes a big triangle with the first joint of the wing and the second joint of the wing.
Mm-hmm.
So that could work.
Good question.
Cool. That's cool. I like learning new things, especially when they come in the form of questions. Very, very neat. Okay. Cool. Okay, I think that covers all the questions that we've had. We haven't got any more coming in from YouTube. Eric hasn't yelled at me about any on the Discord chat. So far, so good. And we're ending on time. So look at that. So
like
thank you.
On time.
Yeah, we don't do it often. Thank you, Chris, for all of that information. That was a ton of information, and I've got some extra stuff now to go out and look for next time that we go out.
Well, just hopefully you've got a deeper appreciation for what you're looking at, and maybe you'll look at different aspects of the sky that you hadn't thought to look at before.
And certainly gives you extra things to remember and to help you remember what's going on up there in terms of I really like the story of the woman and the man separated by the river. So that's a really neat new one that I hadn't heard. And I love hearing stuff like that.
Yeah.
There is one. Oh, the one last question is thank you. You are very welcome. Thanks. Thank you guys for joining us today. And we had a great time as usual. Couple of things that we'll say to wrap up. This Thursday. So in 2 days, we've got a talk with David Levy on at 7 p.m. So if you'd like to come and hear about comets, David Levy discovered a comet that in 1994 broke up and fell into Jupiter, which is pretty cool. So he's going to be on Thursday, next Thursday. So a week and 2 days away, we've got our next Explore the Universe session. So you can join us for that if you would like to. And we're getting into August then. So
in 2 weeks, you and I are back doing the Southern Hemisphere sky.
Yes. So if you want to come back and learn about the Southern Hemisphere, 2 weeks from now is the time to do it. We do have a list. So we're emailing out what's happening each week at the RASC. If you'd like to join that list, I believe it's on our website. I'll see what I can do about sharing that information. Chris left. That's okay, I think. I'll wrap up quickly. And then finally on August 8th, I'm losing track of whether or not that's soon. I think it is. We do have that event with Montreal Center and Ottawa Center. They're co-hosting an event for the Perseids Meteor Shower. And then fingers crossed, Chris is back. Fingers crossed we can get
again just in time.
But to say goodbye. And
you'll have to take all those glitches out in post.
That's okay.
Thanks, Jenna.
Thank you, Chris. One last question, which was, what was the app for the space station? And that was Astrospheric. It's not just the space station. It tells you a whole bunch of other stuff as well. Highly recommend.
You mean the space station? You mean ISS detector? Oh, the one you showed.
The one that I showed, which was Astrospheric.
Okay. That's where I was. I was somewhere.
Yes, that's why you were out. Yeah. Okay, so thanks everyone, and we'll see you all in the coming weeks of fun. And we'll
bye.
See you on this show.
Looking up.
Bye, everybody. Clear skies.
Thanks, Jen.